ESMERA would be trying to help these robotics companies develop their solutions in a number of ways. The first was to actually be able to provide a market for them by creating challenges, creating problems that needed to be solved through identifying this kind of needs in major European industries. The second was that we provided access to state-of-the-art research facilities around Europe so that they can also benefit from technology transfer from these universities and research institutions that have a long experience in developing robotic solutions. And then we also supplemented this support with mentoring and coaching that we're able to give them concrete guidance on what should be the next steps to bring their solutions to the market. And finally, we also provided direct financial support to them by being able to grant up to 200,000 euros.
These are the experiments which have advanced the most during ESMERA. Web2Cut is changing the industrial textile cutting process by using an automated laser cutting mechanism and a robotic piece handling system. This process reduces the unit cost and improves productivity, while also allowing for faster delivery times in high-mix, low-volume production. Prism is a precision spraying robot that reduces spraying losses in steep slope vineyards. This robot is a cost-effective solution which can operate 24 hours a day. Nero is a robotic assistant for spinal surgery powered by a high-precision tracker. This feature allows it to adapt and address scoliosis interventions, even in cases involving complicated trajectories and high accuracy requirements. Flocks utilizes a rover to prevent chickens from over-concentrating in parts of poultry sheds. This experiment is the first of such systems which can actually see what is happening in the shed through machine vision. MOCAS is an assembly workstation which harnesses safe human-machine interactions. This flexible mobile system will improve processes involving threaded objects, which require human attention but can also be optimized through robotics. Romero is a unique distributed system that aims at providing a robust and reliable solution for monitoring active volcano islands and their surrounding areas. Its system includes UAVs, buoys, a control center, and particularly interesting underwater unmanned vehicles. Rover 4RT has developed a robotic vegetation removal system for train tracks. To eliminate weeds on railways, the robot integrates a laser-based system, which is a plausible alternative for currently used herbicides. Suspicion aims to predict robotic failures in spot welding applications and propose solutions to decrease operational downtime. In this ways, suspicion can help industry to deal with breakdowns in production before they even happen, increasing efficiency by up to 30%. Through human-machine collaboration, Reflect aims to automate part of the assembly of dishwashers. Its technology is a step towards better systems with the capability to manage the formable parts in precise assembly processes. Wire Cobots is focused on improving the assembly process of wire harnesses by introducing collaborative robots. Safety, ergonomics, psychological well-being, and production efficiency have all been central to the design of this system. Minotaur sorts debris resulting from the decommissioning of fuel elements of Magno-type nuclear reactors. It applies a robotic arm, an RGB depth camera, and a novel machine vision system to detect fully or partially visible pieces of debris based on their shape. SA3IR has developed an autonomous robot for intralogistic retail scenarios. The robot is capable of moving carts typically found in retail environments, navigating narrow corridors and avoiding people and obstacles. NIX is a tool for conducting inspections in harsh environments, which can be adapted to different robotic platforms. It also counts with an enclosure to protect it from the weather and environmental elements, without impairing any of its operational sensors. Carob can work autonomously for up to 24 hours at a time and can weed carrots with great precision. This experiment is guided by a GNSS RTK positioning system, which grants it the ability to make precise real-time corrections while only causing low soil compaction. Kobo League has developed a robot which can provide autonomous and semi-autonomous transportation for heavy parts in construction sites and industrial facilities. The robot integrates innovative technologies for outdoors localization and safe navigation. AeroWind is an autonomous visual inspection system powered by a UAV. It enables the inspection of wind turbines without requiring the stopping of the blades. In this way, it prevents the interruption of energy production.
This is a great opportunity for SMEs to advance from that. They have in their hands now practical examples, practical applications. In addition to that, challenge providers have spent time to define well-defined problems, but they also had the opportunity to see practical solutions to a number of application areas in their production. So from that experience, they have now the opportunity to see the results and to exploit these results in their production. So that has been a great result for Europe altogether. And further to that, additional support is now available for all of them, since ESMERA has been a key project to generate and to create a number of competence centers. So the future is to continue developing these competence centers, supporting SMEs to develop and test AI and robotics solutions. Another key outcome coming from ESMERA and building on the idea of the competence center is to deliver education and training services to industry so that they can better absorb technology. In addition to education and training, of course, it is possible through the competence center to deliver consulting services to industry to be able to adopt these solutions. And finally, it can help to advance on efforts in robotics research driven by industrial challenges. So we see this competence center to be a key outcome of ESMERA.